All right, everyone, let's go ahead and get going on this. I'm doing this towards the end of seventh period, so we have about maybe 10 minutes before the end of the day bell rings, and you'll probably hear a bell at that time. But let's see if we can beat the clock. Right, homework 6 for chapter 6. Right, fabulous footballers score incredible 55 points during the last night's game. Interestingly, the number of field goals was one more than twice the number of touchdowns. Right, so that means that the field goals is actually more than the touchdowns. Right, so keep that in mind when you're writing that equation. I'm actually going to go ahead and circle that. Right, the number of field goals was one more than twice the number of touchdowns. Okay, and then they scored 55 points. Fabulous footballers earned 7 points for each touchdown, so that's still part of that 55 points, and 3 points for each field goal. Right, so that's the all part of it. So part of it's red, part of it's blue because they are involving different things. Oh, lucky us. Answers are already down here. Just got to pick which one. So I know that each touchdown is worth 7 points, right? And each field goal is worth 3 points. So I just got to look at my possible answers with the 55 points total. So I'm looking at 55 points. They're all on that bottom equation. Okay, 7 points for touchdown. Looks like that one and that one. And these are saying touchdowns are worth 3 points. So it's not, so I know it's not 3 or 4 because these are both 3 points for touchdown. Okay, and field goals are 3 points. So it looks like 1 and 2 works out for that second equation. Okay, so 1 and 2 looks good for that second equation. Okay, let's look at, so 1 and 2 we're gonna say is perfect for that second equation. Okay. First equation, number of field goals was one more than twice the number of touchdowns. Right, so that means that field goals are more. If you look here, this one's saying touchdown is 2 more field goals than plus 1, right? So that means that there's more touchdowns. Okay, this would be wrong. This one says field goal is equal to the number of touchdowns times 2 plus 1. So that means that there's more field goals because field goal involves all that stuff with a touchdown times 2 plus 1. So that means that there's more field goals. So I'm going to go ahead and go with this equation number 2. Okay, so this should be my 2 equations or my systems of equation. Okay, solve the system you selected in part A to determine how many touchdowns and field goals in the fabulous footballers made last night. So using that equation, okay, F equals 2t plus 1 and 7t plus 3f equals 55, right? So we're going to do this using substitution like how we learned. All right, we're saying that anytime we see an f, we're going to use 2t plus 1. And look down here, we see an f down here, right? So as I am copying this, so I'm going to copy this equation, 7t plus 3, and then I'm going to copy f, but remember we said f is actually 2t plus 1. Okay, that's what f is. Right, so instead of f, I'm going to write down 2t plus 1 because, again, instead of f, I'm going to write down 2t plus 1. So I'm copying 7t plus 3, and then instead of f, I'm copying down 2t plus 1, and then copy down equal, copy down to 55. Okay, work on this. Copy down again, 7t plus 3 times 2t is 6t. 3 times 1, because you have to distribute, is plus 3. Again, you have to distribute. 3 needs to multiply into 2t, and 3 needs to also multiply into 1. And copy the rest, equals 55. Okay, going to put this together. Okay, 7t and 6t can be put together to make 13t plus 3. copy the rest, equals 55. Okay. Now I'm going to try to solve this by taking away 3 from both sides. So we get 13t equals 55 minus 3 is 52. Okay. And pulling up my calculator because I don't know what that is. All right, to solve for this, I have to go and divide both sides by 13. Remember, this is t times 13, so to split that up, I have to divide it by 13. Okay, and this will allow me to cancel my 13s and leave me the t. So t equals, I got to figure this out on my calculator, 52 divided by 13, that gives me 4. So that means I get 4 touchdowns, right? So if there are 4 touchdowns, right? And remember, this is my original equation right here. It's my original 2 equations, right? So we said we just found out that there were 4 touchdowns. 4 is a t. So if we work this out, 2 times 4, that gets me 8 plus 1. So the number of field goal is going to be equal to 9. So our answer is, right, 9 field goal and 4 touchdowns. If we write it as a F and a T for field goals and touchdown. Okay. So 4 field goals, 9 field goals, 4 touchdowns. All right. So the question is, hey, how many touchdowns? 4 touchdowns. Okay. Next page. Yesterday, Micah was given some information and was asked to write a linear equation, but last night her cat destroyed most of the information. Okay, this goes with my dog or my cat ate my homework. That's right. All that she has left is that right there. Complete the table and graph the line that represents Micah's rule. Okay, so you look at this. I have some information already. Right, I do have the answer for 3. I'm gonna put it all in blue. So like this right here says that at x equals 3, and that's what we have. X equals 3. That means y equals 3. So my first missing information is 3 right there. Okay. My next missing information, I have it right here, is -2 is the x, and then the y is 1. Right. So if I look at my graph, it's -2, which is 1, 2, and then the y is, actually I'll put that in red. It'll be easier to see on the graph. Okay. So -2 means the x is -2. So it means on the x, I'm going to go to -2 right there. And the y is 1. So I'm going to go up 1. So about right there. Okay. So that is my missing part of the graph. And I can see what's going on, right? So if this is a linear equation, like how they say, then that means that they're all going to behave the same. Okay, linear equation means that they're always going to be acting the same, meaning it's going to always be down 2 over 1, down 2 over 1, down 2 over 1. You can see I'm really careful because there's halfway points, down 2 over 1, down 2 over 1. Okay, so my line is going to look something like this right here. So naughty cat. And if I keep adding that, right, if I look at this, right, -1 right here, it looks like it's at -1, right? But I can actually figure out my pattern because from 3 to 1 is going to be -2. So I want to do the next one. If I want to do the next one, then I just have to go and do minus 2. So 1 minus 2 on your calculator should give you -1. And it matches it with this spot right here in blue. Okay. And again, if I want to keep doing it, got to keep going. Got to go minus 2. Right. So -1 minus 2 gives you -3. And it matches it right here. As 0, it's going to be -3. And if I want to keep going, got to go minus 2 for the next one. So -3. If I take away 2, I get -5. And it matches it right here. So at -1, I get -5. Right? So at -1, +1, I get -5, which matches it right here. And then lastly, if I want to figure out this last one, got to go minus 2. Oops, I forgot to do the -5. To get the last one, I got to go -5 minus 2 makes -7. And if I look here at +2 on the x, I get -7 on the y. So +2 is right here, -7 is down here. So this matches perfectly in. You got to remember not to let your cat eat your homework again. Okay. Okay, almost done. Micah thinks the equation for this graph could be 2x plus y equals -3. Is she correct? Explain why or not. Okay, so 2x plus y equals -3. So I'm not used to doing it like this, and you probably won't be. We're more used to doing it as a slope intercept form. So I'm going to minus 2x, right? And that's going to give me y equals -2x minus 3, which tells me that I am going to start at -3 on the y. So if you look here, that's -3. And this says I'm going to go down 2 and over 1. So down 2 and over 1, and it matches, right? So I think this equation is good. So is she correct? I'm going to say yes, Micah is correct. Because the y-intercept is -3 and the slope is -2. Okay, and it matches it. All right, last one. Kevin and his little sister Kathy are trying to solve the equation below. Kevin thinks using substitution method should give a new equation, while Kathy thinks it should give this equation. Okay, who's correct? Right. So, well, it doesn't matter who's correct, right? Let's do it. Right. So it says. So this one says instead of y, I'm going to put in 6x minus 1. So where do we see a y? Right here. So where does that 6x minus 1 go? Right where the y is. Okay, so my equation, so my second equation, the equation should look like this. Copy 3, copy x, copy plus, copy 2. And then we're going to copy y, but remember, instead of y, we're going to copy down 6x minus 1. That's what we're going to copy. Okay, and then copy equal, copy 43. Right, so who looks like that? Let's see. Kevin thinks it should look like this. Does it look like that? Nah, Kevin. No bueno, Kevin. Right. Kathy thinks it should look like this. Does it look like that? Yes, it does. Okay. So I'm going to say Kathy is correct because the y should become 6x minus 1. Okay. All right. That's a wrap, guys, gals.